How's everyone tonight? Great. Just a show of hands, how many people here are front-end developers? How many are back-end that use JavaScript? How many belong to neither of the above? A few, okay, good. Just so I can highlight a few points when I get there. So I'm Nicholas, I'm from Springworks, and I'm going to give a talk on taming types. So I have a background in mathematics, so typically we start a talk with giving a definition, and I was going to do that, but then realized trying to define what a type is really, really hard. So I'm going to skip that and go straight into a problem. So I work for Springworks, as I was saying, and we develop a connected car platform. Has anyone heard of us? Yes, we do TeliaSense, if anyone's heard of Telia. But basically the main part of this is we have a bunch of small services, and with that comes some problem. We write most of our code with JavaScript, but we also have some of it written in Java, and we have 2 clients in Android and Swift. So this brings some unique challenges. So as I work for a connected car platform company, all my examples will be about trips and cars and stuff. So if you're wondering, that's why. So does anyone see a problem with this code? It's a super simple microservice. This is not production code, obviously. It calculates average trip speed with distance and duration. Anyone? No glaring bugs? There's not really a problem per se, but we make some assumptions. So specifically, we assume that the trip distance and duration are both defined on a trip. And we all know in life assumptions are dangerous. So why is that the case? Well, as I was saying, we have a bunch of services at Springworks. So take a driving statistics service, a usage-based insurance service, or a parking notification service. And these might be written in different languages, developed by different teams, and worked on over time. And we have some service that produces a trip. Typically, we have a telematics unit that sends it to our Java code, and it converts it into some nice JSON object and sends it to other services. So what can possibly go wrong with this? Well, what if we change one of these? You see, changing start and duration to start and end. And one of these services depends on this. So that's going to break. That's bad. No one likes that. So how can we fix this? Well, it boils down to how can we document and validate our assumptions? Anyone have an idea? Yeah, lots of options. Let's go through a few of them. Unit tests. Everyone loves unit tests. Who doesn't like unit tests? Who doesn't like writing them now? Okay, does anyone see why this actually won't help? This is great, a unit test. We test our function. It wasn't particularly complex, but you know, test 10 divided by 2 should be 5. But we still have the assumption here. We still assume that distance and duration are part of a trip. That's the whole point of unit tests. They're isolated from the rest of the system. So this actually doesn't help. What about fixtures? Okay, slightly better. Now we load the trip from a JSON file. And this could be shared across different services. So we can check that what the producer produces, for example, matches the fixture. And that when we load the fixture here, we use that for our tests. Life's good. Problem is, fixtures are, well, fixed, as the name would imply. So how do we actually know that this should equal 5? It's not really a nice unit test. There's no 10 and 5 there. It's kind of implicitly hidden in this fixture. And if we want to test some edge cases, or divide by 0, then we have to create fixtures for all of those. And now how do we keep those fixtures in sync? Same problem again. What about end-to-end tests? How many people write end-to-end tests for their entire service? What about across microservices? It's a bit trickier. Good job for those who do. Nice to see that. It's pretty hard, actually. So here we're spinning up, say, the trip producer somewhere else. That's a server just in this case. And this get trip from somewhere somehow makes a HTTP request there and gets it, or whatever needs to be done to invoke the entire flow of the system. But this is very hard to do. It's great, but we still want our unit tests. We can't test all our services that way. What about static typing? Yes, I know this is sthlm.js. Who likes static typing with JavaScript? Yeah, nice. How do we do it? Anyone recognize this? TypeScript, yeah. You can do a similar thing with Facebook's flow checker. Basically, you define a type, and then you can use that to check. And here the compiler actually makes sure distance and duration are defined on our mock object kind of that we pass into our test. So this is quite nice. If we change our interface and say remove duration, then the compiler will complain. So we know, usually this trip would be defined somewhere central that's shared. Everyone following me so far? Right. So the problem is we use multiple languages. So we need, our producer is written in Java, for example, that creates the trips. And most of our consuming services are written in JavaScript or sometimes TypeScript. So we need a solution that we can have the types expressed in both languages. We also want runtime checks. So TypeScript compiles down to JavaScript that doesn't really have, or sorry, TypeScript only exists in the compiler stage. It removes all the typing information once you compile it. So you can't really check in runtime. So what we really want is a generic language for specifying types. Has anyone heard of any? Yeah. So schema. So basically, protocol buffers from Google. Who's heard of Google? Yeah. Apache Thrift. Who's heard of Facebook? Yeah, most people. So those are great. They're a bit heavyweight for what we're doing. Captain Proto is also written by, I think, the same guy who wrote the original protocol buffers. Don't quote me on that one. XML. Apparently that's not cool anymore. We use JSON for all our payloads anyways. So I had to put a meme. My colleagues always accuse me of not making jokes and stuff. So basically, if we go back to this table, we use JSON already for our REST APIs and other parts of our system. So why not use JSON schema? It kind of makes sense. So why do we use it? We use JSON. It has a lot of validators for different languages. So there's one for Java, there's one for JavaScript, for Node, lots of languages. We already specify our APIs with Swagger. Has anyone heard of Swagger? Or I think it's called Open API Specification now. Super generic name. Yeah, it uses kind of JSON schema anyways, kind of for its objects. MongoDB, we use that. It stores, I guess, binary JSON, but JSON when it comes out. And it's fairly expressive. So what exactly is JSON schema? Has anyone heard of it? Yes, 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 a few people. Great. So JSON schema is a JSON media type for defining the structure of JSON data. JSON schema is intended to define validation, documentation, link, hyperlink navigation, and interaction control of JSON data. I still don't know what it is. It's basically saying it's JSON to specify JSON. That's great. Let's look at it a bit more carefully. Yeah? Yeah, it's very similar. So I guess you could compare JSON schemas to JSON as XML, or I think RelaxNG, or there's a few other ones, are to XML. But we don't use XML, so I guess we use JSON schema for that reason. So does anyone know when I actually started the talk? Just for time. Quarter after. Okay. Thursday. Perfect answer. Then I can go till Friday, right? Okay. So let's go. This is the simplest JSON schema. Line 1. Just an empty JSON object. And this validates against every JSON, as long as it's semantically correct, of course. So empty object, great. String, array of different types, they all validate. Let's get a bit more complicated than that. You can also specify a type restriction on the schema. So this is basically a simple schema that only accepts strings. So you can see an empty object's not accepted. Second line, the string is accepted, and the array, even though it contains a string, is still an array. We can do numbers. You can also, for each type, you can actually specify additional sort of restrictions. These actually apply even if it's not a number. It's a bit weird that way, but typically you don't want to do that. It's confusing. So here, -8 doesn't pass the schema because it doesn't satisfy a minimum of 0. 10.3 definitely does, but 2.345 fails because it's not a multiple of 0.1. So this is what I meant. It's quite expressive. That's pretty typically hard to express in a programming language directly. You don't usually have positive integers that are multiples of 0.1. At least I haven't seen them. JSON is kind of weird with strings and dates. If anyone knows that from doing front-end development, it's really fun to parse date formats. There is one that you can specify, and it's the ISO standard. Don't ask me which number. Basically, it says you have to have a string, and it has to have this exact format. And then everyone's happy. No Monday, April 17th, etc. JSON is JavaScript object notation, I believe. So you'd expect to be able to specify objects. And you can type object, and then you can further specify the properties. And each further property is, again, a JSON schema object. So it's a recursive type definition. And you can also specify that some of these properties are required. So they're not required by default, which I find kind of annoying because usually we specify almost all of them as required, and you get this giant array. So there's an easier way to do it as well. But this checks first one doesn't satisfy. There's no VIN, which is, by the way, vehicle identifier number. It's our ID for vehicles. String fails. The third object passes. It doesn't have distance, but that's okay. It's not required. And you can also have distance. No problem. If you don't specify a property as required, you can add it. But you can also add properties that aren't in your schema, which sometimes isn't so nice because then you can just validate against anything if you had an empty schema, and you never have to add properties. So you can actually say additional properties false, which means you're not allowed adding additional properties. So if you have, for example, fuel, the third object, that will fail because it's not in the schema. So this is both a blessing and a curse. I'll explain a bit later why. Also something fancy you can do, you can take a few schemas and combine them into one. So here, this is basically satisfying both multiple of 5 and multiple of 3. You can also do one of, and then it has to satisfy one or the other. You can also satisfy, it has to be a multiple of, say, 2 prime numbers, and then you're not going to get very many values that actually satisfy it. Or type null and type number. So you can actually specify empty sort of value spaces. Is everyone following so far? Any questions at this point? Yep. Yes, sort of. There's 5 drafts, varying states, and they're kind of hard to read. There's a good, if you just Google JSON schema, I think the first hit that's sort of a tutorial. It explains it better than the standard draft. So it's been around since, I believe, 2010, at least is the first reference to the draft I saw. So, yes, it's currently draft 5, I believe. The old one expired long ago, despite people still using it. So, question? Yeah? Good question. If you know of one, please tell me. It might be better than this. But I couldn't find one. There's a few references, but I haven't found any like in my quick Googling before using this. I looked at, of course, like thrift and protocol buffers and these before. I guess supported is there's validators for most languages and they're open source. So I'm not sure if there's a company backing it per se. Yes. Maybe the strange syntax sometimes, I don't know. Maybe not enough people giving talks about it. I don't know. Let's see. So what can we do with it? So I started off saying that we had a problem that we had assumptions, and assumptions are dangerous, and we want to document and validate our assumptions. So let's see how that we can use JSON schema to do that. So here's our fancy function again. Let's write a unit test for it. So this was the first unit test I had. We saw that the problem is the assumption's still there and it's still not stated explicitly. So this unit test will still pass even if the trip changes completely in the other parts of our system. There's no link back to here. So let's do that. Let's define a trip schema. Super simple. Type object to properties. I suppose they should both be required. Once again, it's annoying that they're not required by default, I would argue, but so if we do that, and assuming they're required, when we have validate against schema here, this makes sure our mock actually satisfies the kind of contract we're building up for the rest of our system. So we can unit test, say, our producer that it also satisfies the schema. If you notice here, we explicitly called validate against schema. There's going to be a lot of repetition because we'll do this in most of our unit tests. So at SpringWorks, we came up with just defining a sort of mock factory that we import. So here it says create mock trip, and we pass in some parameters we want. That way we can write our unit tests. So this is a plus over the fixtures. But in the background, that actually validates and strips any additional fields that we added in or warns about them, and also freezes it. I'll come into that in a second. this is what that would look like. The create mock trip basically assigns some random distance and duration and overwrites it if we pass anything in, so we can write unit tests. And then we validate against the schema. And then we freeze the object. The reason we freeze the object is so you can't accidentally or deliberately sort of set properties on the mock after you do it. You have to remember to pass them in. So just kind of, I make mistakes all the time. If something doesn't tell me I shouldn't do that. So thinking ahead. So what have we gained by doing this? Well, we know this will work in production now. So here we have our super simple service again, where we calculate the average speed from a trip that comes from somewhere. We don't really care where, but we know we're promised basically that it'll satisfy the schema. And actually we can check that in runtime it satisfies the schema. We can also verify with our tests that the thing it's producing, the trip, also satisfies the schema. So we can check both at runtime if we wish. We don't trust the input, say, and we can trust it with our tests, validate it with our tests. So we actually know if we make a change before that our services will still work. So basically, this schema sits between our microservices as the contract between them. It's not a new idea. It's just putting a schema on the programming by contract. But it seems there's not too many options actually for doing this with JSON data. So there's some issues with this approach. Number one, how do we distribute the schemas and the types? So we are using NPM for our node code, but we have Java code as well. So when we make a change to the schema, we have to upload it to some Maven artifact or somewhere, and we have to make sure our code gets updated so that our tests actually fail, because they're using the latest version of the schema. If we've changed things, of course. How do we detect breaking changes? So in the first example, I removed a required field, basically. So I have some code assuming that that exists, and it's gone. So that's definitely a breaking change. But can we detect this automatically so I don't have to think about it or run tests, for example? Should we version our schemas? So as I said, we had a breaking change. We can't update all our services at the same time. So actually, we want to version them and support both at the same time. So how can we support multiple versions at the same time in production? So these are actually all hard issues that we haven't completely solved. But this is not unique to this as well. Yes, question? Yes, currently. That brings me to another point. Thought I had another point. I did not include that. I'm sorry. So I'll wrap up quickly and then I'll find my additional slides since I still have time. So what have we learned? Assumptions are dangerous. Pretty clear. Documenting assumptions with schemas, good idea. Using your schemas to validate your mocks for your unit tests, great idea. Combining with static typing, this is my extra slides. That's really cool. I'll get to that. And we still have some work to do. So all those open issues, how do we version, how do we distribute them? That's sort of ongoing. Are there questions at this point? Think about a question while I pull up my other slides. No one has questions? Yes. Yes. But how do we still use different programming languages. So we still need, I've never seen a sort of type language that supports both JavaScript and TypeScript and these. I mean, there's Apache Thrift and these protocol buffers and things, but also Json Schema. So it might help with at least the versioning problem, for example, and the distributing. That definitely helps. But the fundamental problem there that we still don't have a common sort of way of expressing our domain types still there.
I mean, one way I've seen it done before is the JS side will just naively use schemas and then use it with the validation library.
Mm-hmm.
But then the Java code base, we're expected to use code gen to generate Java beans with the annotations of the validation.
Mm-hmm.
And I think they get to Japanese with thought it would be to do that.
So if I understood you correctly, you're using the JSON schemas or some.
JSON schema to generate properties.
Yeah, that's great. That's I'm hunting for my extra slides. The combining sort of with the static typing. So that's definitely a nice way of doing it. So were those the two related questions? Yes? Yes. Actually, TypeScript ones, because we use TypeScript, but it would be pretty similar for Flow. So I'm getting a lot of questions about that exact section I seem to left out. Give me 1 second to just find it and add it to my talk. Sorry, I wrote everything in Vim, so bear with me for a second. Yes. No. What did I even call it? It should be... it's TypeScript. I'm glad I prepared slides. Doing a live dev coding is quite fun. Yeah? So sort of the mock factory you saw, I had this generate random. I guess you're suggesting generate that from the schema. That would be awesome. Are there libraries for that? Okay. That's very cool. We should talk after. Yeah? Okay. We'll also have to talk. These are great things. So I have my slides now here. Quick check. Okay. How am I doing for time? Do I still have time to? Okay, great. Let's go. Best of two worlds. Here we go. TypeScript or Flow. I guess they're pretty similar now. So why would we want static checking? Well, everyone sort of raised their hand, so I don't really need to sell you guys on this. But basically, if we have some optional property, this max speed, it gets a bit tricky when we generate. As long as all the properties are required on our JSON schema, it's okay to generate unit tests because it's pretty easy to generate a mock that tests most of it. But as soon as you have a bunch of optional properties, you get this kind of, okay, I want to test with these properties there, with these properties gone, and it gets a bit messy. So it'd be nice to have a tool, say a compiler, that actually checks that you're doing things rather than unit testing and basically replacing the compiler with unit tests. So here, this will actually warn you that you're trying to use max speed without seeing that it exists. So that's, I mean, I won't sell you on TypeScript. I like it. We're starting to use it a bit more. But we need to combine them with JSON schema since we define our domain types with JSON schema and not with TypeScript. So basically the idea is generate TypeScript types from the JSON schemas. Or actually, interestingly enough, the reverse. Write TypeScript and generate JSON schema from that, since most of our code's in JavaScript. There's some issues. Once again, we can't encode all the features of JSON schema in TypeScript types. So this weird multiple of 5 and multiple of 3 and greater than 0 sort of thing, that's a bit tricky. Those are dependent types, and that starts to get interesting. There's not really a polished library for this, at least not that I've found, that takes a JSON schema and gives you a nice type definition. And we also need a library for every language we use to be able to do this. So we need one for Java, we need one for TypeScript or Flow, for example. So, yeah. Any more questions? Thanks for the patience there. No? Then thanks for the attention, and thanks to Google. Yeah.